Hi, welcome you all for the example session in building optimal binary search tree. Let's consider sorted array of search keys which is represented with the variable name key from index 0 to n minus 1 and an array of corresponding frequency values with variable frequency from index 0 to n minus 1. We have to construct a binary search tree with all number of keys given here such that the total cost of all the searches as small as possible. That means we have to find out optimal binary search tree which should give minimum search cost when you are searching the value in this binary search tree. The cost of binary search tree node is the level of the node which is multiplied with its frequency. That is, level of the node is multiplied with its frequency value. The level of the root node is always 1. Example, let's define the cost of BST by using this example. Keys are 10, 12 and its corresponding frequency values are 34, 50. So we have to find out the number of possible binary search trees by using the formula 2 times of NCN divided by n plus 1. When you are substituting the values, there is the possibility of 2 number of binary search trees by using the n equal to 2 number of keys. So here the cost of your binary search tree node is the level of the node multiplied by its frequency value. And here when you are constructing the tree, you look at that. First we are taking 10 as a root node and then remaining node is 12, so which is greater than the root, so we are added as a right child. Then when you are taking the next tree, here 12 is the another possible, that is possibility, that is taken as a root, and remaining is only the 10. The 10 is less than the 12, so we are adding as a left child to the 12. Now the frequency values to be written here. 34 is here for the 10, or 50 is for the 12 for the first subtree. Here when you are multiplying that frequency value with the level, so here 34 into 1, the root is level 1, 50 into 2, so here the level is 2. So when you are adding like that, here you are getting the 134 as the value for the tree 1. Then tree 2, here you see the 12 is having the frequency value 50, then level is here 1, and 10 is having the frequency value 34, and level is here 2. So when you are multiplying this, it is 68, this one will give you 50, and based upon that you are getting here 118. So here among this both, which is the minimum value? This is the minimum value, so this is the optimal binary search tree in the given example, not the first one. Likewise, here the second example is given with the two number of keys 10, 12, 20, and its corresponding frequency values are 34, 8, and 50. Based upon this, how many possibility of binary search trees? So here 5 number of binary search trees are possible. Based upon that, we are going to construct the value, binary search trees. Then frequency values has to be mentioned here. For 10, 34 is the frequency value. For 12, 8 is the frequency value. For 20, 50 is the frequency value. So here we have to identify the search cost. So here the level into frequency is the cost to calculate. So here the level is 1 into 34 plus 2 into 8 plus 3 into 50. So for that, here when you are substituting like this, here you are having 200 is the value. For tree 2, here we are going to calculate by using this formula. The level is 1, here the level is 2, and here the level is 2. So when you are substituting the values by using the frequency, for 12 frequency is 8, for 20 frequency is 50, for 10 frequency is here 34, right? When you are substituting the values here, you are getting 176, right? After that, for the tree 3, you are getting 168 based upon the values here. You are substituting the level is 1 into the 20 is having the frequency 50, 12 is having the frequency 8, 10 is having the frequency 34. This is the level. So when you're substituting the values here for the tree number 3, 168, then tree number 4 here, level 1, level 2, level 3 into frequency of here, for 10 frequency is 34, for 20 frequency is 50, for 12 frequency is 8. So now you are getting 24 here and 100 here, 34, you are getting the 158. So like that, when you are calculating for the tree number 5, 142. So among those, 142 is the minimum. So this is the optimal binary search tree in this given example. Thanks for watching.